Welcome back to our channel and back to the tutorial for deep learning. So we have to continue the topic called this PRAN, that is parallel reverse attention network mechanism. So it's one of the novel unique attention mechanism where always helpful to extend the deep learning models that are, and also it always contains the parallel and reverse attention for more and more accuracy. Moreover, it always very useful in the field of image captioning, visual QA, and etc. etc. So, we here now the basic things of parallel reverse attention method. One, because it's one of the successful deep learning architecture and model utilized for medical image segmentation group here. And so, if you want now this about this attention mechanism, we have to consider these points like mimics human things and boost model interpretability, and also very popular because it always supports and have self attention and some other methods to here, and always focus on some particular data and close and close parts to enhance and extend the learning process here, and always helpful to explain model decision through the focus patterns here. Very important here. And how it works. So once come to the point of how it works, it also based on the deep learning where follow the CNN model. So it have a procedure like initial global map and followed by reverse attention and plus iterative refinement. These are the three things we had considered about the PraNet. And the main thing is when you go for PraNet, we can go for medical image segmentation, and we can go and combine with some other model here. If you want, we can come to some other architecture, and we can go for further enhancement here. And reverse attention mechanism. So before consider this point, there are three things are important. Once come to understand about the PraNet here, that is backbone feature extractor. Next one is the reverse attention models. The reverse attention, where is a part of parallel reverse attention model. And here, first you have to think about now about the backbone feature extractor, because it usually a one and always uses a pre-trained CNN model like ResNet or VGC2 here. Moreover, it always helpful to extract the multi-scale picture from the input image, and also helpful to now more information about the spatial and semantic information are different level of abstraction to here. So what are the complex images or whatever there, we can go for apply the front here. And parallel reverse attention model, because it's one of the specialized part of the PraNet, and where it consists of a reverse attention here, because this reverse attention always help the network focus on the hard to segment regions are usually bounded or even small. So if you have image, so like this, once apply the image, you want predict whether it's a given image is cat or dog or both available, where we can approach the reverse attention model, because it helpful to entire party. So whatever the object is there, so whatever the things there, whether the object is there or hidden, whatever there, it exclusively go and check whether it's there. If the object is there, it try to deduct, at last helpful to get the result here with the help of convolution, future map, and so on, etc. like that. And moreover, this kind of parallel structure means multiple RA models work simultaneously for capturing the details in deeply here. And PRAN architecture. So once consider PRAN architecture, it follow the concept of forward and reverse attention process, and the input always come under the continuously. And concept fusion layer, where it helpful to combine insights from both branches to capture the detail here. And next third component is important, that is aggregation, or you can say fusion layer. So once you want to work with the PraNet, we have to understand these things. Fusion layer. So here the output of all the parallel models are combined to produce the final segmentation mask here. Moreover, here the fusion is done. How means with the help of conversion layer and upsampling to match the input image size to here. And Now the question arises, why we need this kind of prawn architecture? Because and before this one here no implementation. So if you want implementation, you can go ahead with the data set like publicly available data set or science bank like COCO, and backbone networks maybe VG SNet or VG net rolled, and optimization. Here optimization is what get the best solution for the given problem. So we can train with either ADAM or any other algorithm to here. And hyperparameters. Here we can tune the learning rate and batch size for test and good results here. And experimental results. So once come to the category of experimental with this prawn is good only because it have baseline model and always give the more accuracy here. I told you. So any image is there or object is hidden or not, what are the hidden object, everything we can go ahead with the help of this prawn here, identify easily. And qualitative analysis followed with that one, where study is also very important, and applications of prawn here. And why we need this kind of prawn? Because there will be three strong reasons you can say. One is called better boundary recommendation, that especially used in the medical images. So as just now told, there will be a lesion. For example, take any image, there will be lesion is there or not, anything in the kidney or any part like that. And next one is the focus on details. That means here the reverse attention is there. It always highlight the uncertain regions that need to refinement. So suppose you have doubt about this whether this example of cat image only anything is there here not, you can go and train with the reverse attention model and find out if it is there, it will find out the thing, otherwise not. That is possible. And accuracy and efficient and lightweight too here, because this is always helpful to design and effective even if you have a very less training data. So applications of the prawn where we can apply today, the starting it only image captioning and visual question answering and atlas object detection. That means always helpful to improve the small and hidden objects very effectively here. I hope that you understand today what is PraNet and why we need the PraNet and what is the application of PraNet and what are the components of PraNet and so on. If you like the video, please subscribe and share with your friends. Thank you for watching the video.